Hey, Mboss again. I'm back with a follow-up video and hopefully some better audio this time. This one will be shorter too. I just want to show the design updates to the train build. So, straight into it. Last video we learnt a couple of key points. Firstly, don't transport or handle scrap. Reduce train traffic by processing scrap into raw unsorted feedstock as soon as possible. Maybe even on the scrap patch. But also, loading unsorted products is hard. I knocked this up at the end of last video, intended to show consolidations of high stack size products into the first wagon. It's quick and dirty though, it doesn't work great. It is worthwhile pursuing though still. There are benefits to consolidating and stripping the low value products. But it's harder than just to flip and use logic to consolidate. Consolidating is involved and messy, especially if you have to manage multiple belts. While it looks it, it's actually not slower than loading scrap. See back at the recycling here, this is almost 8 belts, while the one below is only doing 4. The main problem is the mixed trains always get stuck at 98%, always waiting for that last item to fill the stack. Unsorted would instead have to use a configured loading timer or something, otherwise you will reduce your throughput. This still doesn't show the overall issue, which in my mind is the unnecessary product handling steps. The original plan was to create a single large sorting array and buffers like previous train base. Remember this setup? It would be able to handle, say, 20 to 30 unsorted belts of raw products in. This would be fed by many smaller mining outposts delivering trains of processed unsorted product. The outposts would all have implemented the density improvements to reduce train traffic, and also local power and rocket fuel from solid fuel and water. As it was pointed out in Friday Facts 426, this one, research search and assembler GUI improvements, LDS stack size has been bumped up to 50. Yes, that's going to hugely help. But still, after all that, I designed a choke point. Let's block diagram this quickly. Let's say the train base is designed for 32 belts of unsorted product using blue belts. A 4 belt outpost and my standard 1-4 trains. Train is loaded about every 30 seconds. So for the sorting hub, that would be a train every few seconds in and roughly the same amount out. I've never got to the point where I've needed to support about 1 train per second in one location. Usually I plan to decentralize long before I need to design such high throughput stations and junctions. So the process looks like this. We got mining and processing, load onto a raw train, unload at sorting, load onto sorted buffer trains, send to users. I think you see where I'm going with this. Instead, let's just consolidate all this and build many small, decentralized sorting and buffer stations using vanilla train logic too. Awesome. So, what are my requirements? What do I need? I don't want it to be huge. I don't want fields of blue splitters at every mining base. For an outpost, I'd prefer not bots as well, so that just leaves inserters for sorting. Size, I think 2 to 4 blue belts is a good size for a large mining outpost, so set 4 belts as the maximum. Now, if all the sorting is pushed all the way up to here, I'll need to be able to handle overflows somehow, ideally without dispatching a train for recycling, as these outposts could be a long way from the core of the base. Because buffers are where the trains get loaded, the buffers are going to be distributed too. So we'll need to communicate individual product levels, but that's a problem I've solved before. I do want a nicer dashboard built into each station, so I don't need to check back at the hub all the time or hover on specific wires. Similar to my standard train network, the stations all need to auto-balance, so use the same algorithm of closest station to the demand which has above average stock level. Defenses, TBA. We don't know about Fulgora's enemies yet. My bet is hostile flying drones, similar to an angry construction bot. A destruction bot? Maybe tries to pick up your buildings and take them away to an enemy recycler? Anyway, nothing for now, leave that as a future requirement. So here's a mining outpost, each loading 4 belts onto train buffers. Step 1 was to simulate a scrap processing outpost that makes 4 belts of unsorted raw products. If anyone still has reservations about quality, here's 3 blue belts being processed using max quality, and here's the belt that doesn't. As covered in my last design, ice and solid fuel get locally enriched, and for training purposes I'm stripping out uranium and oil barrels. Those would just take up additional space in this build. The basic plan is to have the trains lined up like this, so a single flow of unsorted feedstock flows past all the trains, and filtered inserters load the relevant products onto the correct train. Anything not picked up is consolidated down into 2 loops back to the input. It is a loop, but it's not a sushi setup. The normal definition of a sushi design includes circuit controls to manage inflows. I've just got these 2 priority splitters here. What I did do was swap the left 2 belts into the right 2 going in, just to make sure that the chests will balance a bit. On balancing, the main thing I did is this logic here. This is modified from my standard train build. Firstly, I need to calculate the average fill level from each chest. Similar to other self-balancing loaders, only the above average chests load into the train. So usually that's 2 out of 4 chests loading. This is enough to keep the fill levels relatively constant. One option here is to shrink the trains down to 1-1, but I'm used to having at least 4 wagons, so I need to find a way to fill all the wagons from the balanced supply. I played with a few different designs, but I found the simplest was actually to make sure all the wagons got filled from the first wagon, which was balanced. Loading speed isn't an issue, as 4 belts of unsorted products is maximum of 1 belt of gears. Everything else was way lower. So I just needed to be able to handle a single belt flowing back to the wagons. Once the train is full, similar to my last design, if a station buffer is above the average fill level out of all the stations on the green network, green for global, the train was released to supply stations demanding train loads of different products. If there's no demand, the buffer will eventually fill. This line activates at 95% full and directly feeds into the same scrap recyclers. Also, because the rocket fuel is made here, I can fuel all these trains directly. That's this line here. Because I was monitoring multiple identical stations, I needed to upgrade my standard dashboard. I wanted at a glance both the product average and this local station's fill level. I like how I can just scan down the loading yard and see if any trains are having problems. The main benefits being distributed, scalable, communicating buffers, load balanced. If a demand station turns on, it is automatically fulfilled by the nearest station by train distance. The improvement of this design over my previous train yard came with the realization that overflows shouldn't lead to train movements. This design only dispatches a train to a user, not for recycling. In the previous build, all train traffic was between buffers and recycle stations, so all the traffic from the previous build is gone. Slow loading of trains is not what I'm considering an issue. It only needs to be fast enough to deal with the 4 belts of unsorted scrap coming in. It only really uses belts, which means it's got a greatly reduced setup cost to my previous train scrap base, which had the enormous splitter array. I'll show it here. To improve the experiment this time, I needed the base to draw a load. Here's a base, basically cheating in with max quality tiers. It's sized to put out just over 2.7 thousand science per minute, which is a blue belt of each science. It wasn't until I added this load and actually turned the trains on that I realised I'd screwed up royally. This is why I was testing though. It wasn't until the shakedown that I saw why it actually failed. While I like the simplicity of the design, having the first wagon balance itself and the rest of the train, it causes some real problems when the train isn't there. Even worse, the way I've set it up, the train is released from the station by the logic when the wagons are full, and it is a preferred supplier, as in above average buffer size. My oversight here was a train released from the station but still sitting waiting does not interact with the inserters. This means that as soon as the train is full, or if it gets deadlocked on its journey, it stops feeding the overflow loop. Oops. This eventually jams the whole loading loop, killing the outpost as a whole until the train is finally requested or the buffer is manually cleared. So now this puts constraints on supply stations. Stackers aren't allowed, and trains can't idle in an unloading station anymore. This limits throughput and means we are back to having to carefully balance product demands just to keep the system working and constantly clearing jams. Lastly, just an aesthetic one. I don't like how it deals with raw ore. It was an afterthought. I only remembered that raw ore would be a product after it ran for an hour or so and the concrete buffer finally started overflowing. It works, just not something I'd proudly show off. In a future build, I'll split off and handle the iron ore similar to how I deal with solid fuel, keeping the ore entirely out of the loading loop. So I worked a bit more and finally fixed the deadlock issue by incorporating some design elements from my very first crack at scrap, which was the kickstart cell. Do you remember this guy? It's wasted feeding an assembler. I really should have remembered this design when coming up with my train loading. Reducing the buffer size to 2 chests seems counterintuitive, but it means that 3 inserters per chest are available again. So now the chests can individually overflow. You don't need to worry about balancing them against the other chests. This actually also improves loading speed, as the chest to wagon balancing reduced it from 4 stack assemblers down to an average speed of 2 anyway. Also, the logic is much simpler. Look at the difference in wires from this to this. one lane of flow comes from the wagon and the other lane comes direct from the buffer chests. This way, even when the train is missing, a half a belt can still be recycled. This is enough to deal with 2 belts of unsorted raw feedstock, as 2 belts would be a half a belt of gears. Lastly, if you were worried about the reduction in overall buffer size, you can make a trade-off. Extra chests can be added on the rear wagons at the cost of increased train yard footprint and extra splitters to balance loading. It would also add extra complexity, as ideally you would add some wires and circuit conditions to balance the stock levels of these chests. It would provide the ability to rapidly fill a train, but I like the simplicity of this one, and the intention is to have 5 or more outposts, so one station is never going to need to fill a train that fast. It's still not perfect. I think its main weakness is, again, similar to many train bases, the space and infrastructure to handle 4 belts of scrap. I know it's as simple as dropping a blueprint, but something this size still won't fit on the smaller islands. Look at the size of one of these outposts and check that island image again from Friday Facts 399. I think I'll be able to fit this on medium and large islands only. So to access the small islands, which have unrevealed special significance, we are probably going to have to make modifications to this. Maybe link it in via disconnected rails just to ferry unsorted raw feedstock over the water. So, wrapping it up now with what did I learn from these 2 videos? The big new lesson from this build is kind of a meta-learning. If you're experimenting, nothing you design is wasted so long as you learn something. My first attempt at scrap handling unit, the kickstart cell, it was inherently stable, but it was too slow and wasteful to be useful. And this sorting outpost here was designed to be efficient and fast, but turned out to be prone to jamming. Picking and choosing the elements from the 2 designs means an efficient and robust build is possible, but it's only possible after you've learnt the lessons from the previous 2. I'll include the key takeaways from my last video too, as very few people got to the end of that one. Number 1, don't be afraid of buffers. If a product is buffering at the outpost, it's not being immediately wasted to maintain throughput. Less wastage means less outposts required for the same factory throughput. Handling, loading, unloading, and transport infrastructure for scrap is significantly less efficient than processing at patch. Even unsorted raw products is going to be 3, maybe 4 times efficient per train journey, even if you do no outpost processing. LDS stack size is 50 now. Imagine if rocket fuel gets this too. Outpost processing improves that further. Solid fuel is free, available from anywhere from the heavy oil, and so not worth transporting at all. Use what you need locally, then either refine it up to rocket fuel or maybe just dump it. You need to process a lot of scrap to make the buildings and rails to build out your base. So you see throughput increase dramatically if you spike your building more with low tier items from off-world. That's iron and copper plates, and depending on what you are doing on Fulgora, sulfur or coal. Lastly, I really enjoy making these videos, and I think I'll be making some more, both before and after the expansion release. I just wish I had more time. They take me a lot longer to make and edit than I ever thought they would. Just what I needed, a new hobby. Thanks everyone, see you around.